Hello everyone. So, we will continue with the technical textiles understanding, basic understanding part. Now, what we were discussing in last class was that the fiber properties, what are the basic fiber properties for technical textiles. So, although specific technical textiles for specific application requires certain specific property, but in general the main properties of fibers required by many textile application for their technical uses are mechanical properties. This is the basic properties where we need to have better strength, we need to understand the extensibility, modulus and elastic recovery. These are the basic mechanical properties of any technical textile fibers. We may not require that high strength for apparel textiles, but for technical textiles we need strength at least for some specific area. Then comes thermal and thermomechanical properties. In conventional textile, the melting point is not that important, but for technical application, particularly high temperature application or composite application, we must know the melting point of fiber. Depending on that, we should select the areas of application, and also most important characteristics is the mechanical property at high temperature. At normal temperature some fibers will have higher strength, but at higher temperature if the mechanical properties deteriorate, we should not use that fiber for particular application. Next is chemical characteristics, which is very important, whether the polymer is chemically reactive or chemically inert, that decides the areas of application. So, chemical characteristics, the resistance to various inorganic and organic chemicals are important, particularly say for geotextiles. We must use such fiber which are relatively chemically inert, like polypropylene we use for geotextile application, where the fiber does not degrade by chemical reaction. Electrical properties is also very important, like static built up, dielectric behavior. Okay. So, the fiber should have insulating nature, aging behavior, oxidative or thermal aging, that we must take into consideration. Surface properties, adhesion, moisture transport behavior, optical properties, and there are various special properties which are required for the fibers to be used for technical textiles. So, we must understand, we must characterize the fiber before we select the particular fiber for a specific application. So, if you see at present around 80% of the technical textiles are being used for the normal application, where we use everyday polymer and materials like cotton, viscose, jute, polyester, polyamide, polyolefins. These are used typically around 80% of technical textile application. Rest 20% we use high performance textiles fibers, and these fibers we sometime required to modify the shape and dimension, like we change the cross section of polyester from circular to different shape polyester fiber for high absorbent application, like sports textile, active sports textile we use polyester, but not normally circular cross section, various special cross sections are used. Also the same normal polymers we convert it to hybrid or bicomponent product to be used for technical textile applications. Also the normal polymer, if we modify the spinning process, we can achieve high tenacity, high modulus fiber which may be used for technical textile application. So, if we talk about the normal fibers like viscose, it is used for technical textile application due to its excellent resistance to high temperature. So, where we require this high temperature resistance characteristics, we may select viscose, like in automotive and industrial equipment market we use viscose fiber. It has good absorbency, suitability for processing in industries of wet laying technique. So, viscose fiber is used for wet laying nonwoven due to its good absorbency characteristics. The applications are nonwoven industry, especially in disposable cleaning and hygiene end uses, where we need absorbency characteristics. Then polyamide fibers. Polyamide has high strength, very good abrasion resistance. So, the applications where good abrasion resistance is required, the polyamide fibers are being used. It has good elastic recovery, elasticity, and uniformity is good, better resistance to moisture, excellent energy absorbing property, that is higher work of rupture. So, this characteristics, higher work of rupture, due to this characteristics the polyamide fibers are used for rope. The applications are parachute fabric, tire cord fabric, polyolefin like polypropylene, polyethylene. These fibers they have low cost, easy processability, lighter in weight due to lower density, good abrasion resistance, good moisture resistant. So, their moisture absorption property is good, that means they have almost 0 moisture absorption property. Polypropylene has got almost 0 moisture absorption property. These characteristics we use for technical textile application. Due to its surface characteristics, it wicks liquid, particularly water, at very faster rate. The applications of polyolefin fibers are sacks, packages, bags due to the high abrasion resistance, carpet backing, furniture lining, ropes, netting. So, all these applications are there. Okay. And the newer application areas like artificial sport surface. The disadvantage of polyolefin fibers were basically earlier it was thought that they have poor temperature resistance because of their lower melting point, and they are hydrophobic in nature. But these disadvantages, apparent disadvantages, are being used as positive point in technical textile manufacturing like nonwovens. Melt blown or spun bonded nonwovens are easily manufactured from due to its lower melting point. It has good moisture wicking properties which helped its use in the hygiene products like diapers and napkins, where we need very fast moisture transport characteristics, keeping the skin dry, as it does not absorb moisture, it is hydrophobic in nature, but at the same time it wicks very quickly. Now, let us see this polypropylene. Suppose this is the fabric made of polypropylene, and here it is a human skin, and for diaper application, so inner layer which is in contact with the human body, where liquid is generated, due to its very high wicking characteristics, this liquid is being transported to inner core. There are inner layers, leaving this skin entirely dry. So, this skin becomes dry. At the same time, as this fiber does not absorb moisture, so there will not be any water accumulation in this surface, though. So, the person will feel comfortable. So, these characteristics is very important for hygiene products. As I have mentioned that lower extrusion temperature made it suitable material for technologies like spun bonded and melt blowing. So, to reduce the energy cost, apart from the normal fiber, high performance fibers are also being used. So, though technical textiles industry still consume 80% of commodity fibers that I have already mentioned, the really high functional application requires high performance fiber. There we cannot use commodity fibers. So, some of the fibers are like aramid fibers, meta or para aramid fibers, carbon, glass fibers. These are coming under high performance fibers used for technical textiles for very specific application, where we cannot use commodity fibers. The aramid fibers, they have special characteristics. They are lighter, like 43% lighter than glass fiber, with a density of 1.44 gram per cc as compared to 2.5 gram per cc for glass fiber, with very high strength. They are twice as strong as E glass, 10 times as strong as aluminum, and approaches the strength of high strength carbon on a specific tensile strength basis. So, these fibers are very strong fiber, they have low density, high temperature resistance, particularly meta aramid fibers are high temperature resistance. Nomex is a fiber produced by DuPont. Their applications are protective clothing and similar high temperature application. High strength and high modulus para aramids, like for example Kevlar, these are used for bulletproof vest, tire reinforcement, ropes. So, the high strength and high modulus fibers are used in this area. So, these specific requirements, specific characteristics are not present in commodity fibers. Next fiber is that carbon fiber. It has very high tensile strength, very high tensile modulus, high temperature resistance. Due to all these characteristics, they are used in aerospace, high technology sports good, reinforcement in fuel tank, wind generator, wind turbine. So, turbine blades. So, they are reinforced by carbon fibers. So, the developments in fiber materials are, to continue with, then it is a glass fiber. It has got excellent ignition resistance. So, we can use in high temperature application, very high strength, stronger than steel with the same diameter. Its sunlight, mildew, bleach, weather, chemical resistant. So, we can use all in all these applications where sunlight degradation due to mildew, bleaching, weathering, chemical, so are there. So, the application areas are high performance composite, packaging, protective clothing, filtration, mainly high temperature filtration. So, body panels in automotive. So, all this area we can use glass fibers. The other fibers are PBI fiber, which is synthetic fiber with very high melting point. it has exceptional thermal and chemical stability, and it does not really ignite. So, these are the fibers which are used for very specific technical textile application. So, PBI is used for firefighter clothing. It has got the other fiber is that ceramic fiber, high modulus polyethylene fibers. So, PBI fibers, their basic characteristics are it is stable at very high temperature, like around 1000 degree Fahrenheit continuous temperature exposure, it is stable, and its melting temperature is around 1400 degree Fahrenheit. No specific melting point up to 1000 degree Fahrenheit will not ignite, okay, retain fiber integrity. It has low shrinkage, high strength retention when exposed to high temperature. It is dyeable, so we can dye the fiber easily with the basic dye. Mildew and age resistant, abrasion resistant, low thermal conductivity, and it is resistant to most of the chemicals, and it has low electrical conductivity, low static electricity buildup, and resistant to sparks and welding spatter. So, this fabric, that is why these PBI fibers are used for welders clothing. So, the major industrial applications are high performance protective apparel such as firefighter cloth, astronaut suit, high temperature protective gloves, welders apparel as I have mentioned, race car driver suit, aircraft wall fabrics. So, these are the applications of the PBI fibers. Now, we will discuss the textile processes. So, after fiber we have to now modify the textile processes for technical textiles. We have to reorient the conventional textile process towards the technical textile manufacturing processes. There are different processes being applied for yarn manufacturing. Core sheath structure of yarn, which is by friction spinning, is widely used for technical applications. So, core sheath yarns are not normally used for apparel application, where these are used for technical applications. As far as fabrics are concerned, weaving still plays a major role in manufacturing of technical textiles with modification also. So, 3D weaving, creamless weaving, so they have been modified. Normal weaving has been modified to these areas for newer applications. It has been forecasted that nonwoven will overtake weaving in terms of total weight, because nonwoven has got their versatile characteristics. Apart from weaving and nonwoven, other applications are manufacturing techniques are knitting, both warp and web knitting, although warp knitting are majorly used for technical application. Braiding is also one area which is used for technical textile manufacturing. Now, I will discuss the applications of technical textiles. The areas of applications are the transportation textiles. These are the textiles where they are used for cars, lorries, buses, trains, ships, airspace. So, any transportation where these textiles are used are termed as transportation textiles. It is the largest end use applications of technical textiles. Around 20% of technical textiles are used in transportation industry, where the carpets of cars, buses, trains, airspace, carpets, seat covers, tires, belts, safety belts, airbags, filter, composite, reinforcement. So, all these areas, it is for composite body where technical textiles are used. So, advantage of using such technical textiles in automobiles are mainly it is a reduction in weight, which actually in turn enhance the fuel efficiency. Longer life of this technical textiles used in transportation industries. Flexibility in design, we can change the design easily, which is not possible for other products, like the inner lining of car for sound insulation. We can easily mold depending on the dimension or design of the car or carpet. So, flexibility in designing is there, and we can produce quickly. So, due to all these advantages, technical textiles are largely used in transportation area. Next area is that industrial products and components. These technical textiles are used for basically industry, like filter, conveyor belts, abrasive belts, reinforcement, reinforcement for printed circuit board, seal, gaskets. These are all textile products used in industry. Non-ovens, normally it is actually taking over the oven fabrics in these areas. Composite reinforcement suppress both the types of sectors, like composites are used nowadays in industrial application. In medical and hygiene textiles, these are the high volume, but low cost product. There are two types of application. One is high volume low cost product, another is very specific, very high, very expensive products. As far as hygiene textiles are concerned, they are high volume, but low value product like wipes, baby diapers, adult sanitary and incontinence. These are non-ovens are dominated. And on the other hand, there are technical textile product we used in medical and hygiene application, which are very expensive, high value, but used in small quantity. These are basically medical and surgical products like operating gowns, drapes, sterilization packs, dressing, sutures, orthopedic pads, these are actually used in small quantity. There are another area where the products are highly specialized and very expensive. Of highest value products are artificial ligaments, veins, arteries, skin replacement. So, these are the areas where technical textile products are used for these specific applications. In home textile also we use technical products. So, main application of technical textile in home textile area is waddings and fiber fill application, where hollow fibers with excellent insulating properties in bedding and sleeping bags are being used. Foams are being replaced by technical textile product due to the health concern. Woven and non-woven fabrics are used for carpet and furniture backing. Dry laid and hydro entangled products are used for household cleaning application. So, these are the technical textile product used for home textiles. Clothing components, in clothing components apart from normal textile, we use technical textile products like sewing thread, interlining, insulation, waddings, these are technical textile products used in clothing components. Fiber fill products, and latest development of incorporation of phase change materials into insulation product to cope up with sudden extreme change in temperature. So, the phase change materials which are technical textile products are being used as clothing components. In fishing industry, we use technical textiles like nets, ropes and lines, we use technical textiles. High modulus polyethylene being used for lightweight, ultra strong. So, the polyethylene being used for nets due to its lightweight and low absorption. In agriculture and horticulture, we use technical textiles in wide areas like covering and protection of and containment application, like conventionally we use heavyweight textile like jute, sisal are replaced with the lightweight materials like polyethylene, polypropylene. Lightweight spun bonded fleece used for shading, thermal insulation and weed suppression. Basically, where weeds are coming along with the actual plants, if we cover the area with this type of fabric shading, keeping the other zone ready for the plants. So, weed will get suppressed and effectively this will die. Like if we see, this is the field, and if we cover the field with weed suppression technical textile, the fabric will have holes, okay, with specific area where we want the plants to grow. Okay. these are the required area where plants are growing, but remaining all these areas we do not want any weed to grow. So, if we cover this area with this type of cloth, so weed will automatically die. Okay. So, this area is being used and heavier non-woven, woven and knitted structures are used for wind and hail protection. Another area where non-woven technical textiles are used in agriculture, it is called preceded non-woven, where non-woven fabric within the structure already it is preceded, seed has been actually incorporated within the structure. Now, that total non-woven mat is laid on the surface, and these non-woven fabrics are generally it is a biodegradable natural fiber like jute non-woven is being used, and with the time from the seed plants will grow and the fabric will get degraded. Okay. So, that is one area of technical textile. Capillary non-woven mats which are used to distribute moisture to the growing plant. So, non-woven mats, capillary mats are used to moisten the plants. Bulk storage and transport of fertilizer and agricultural product, where polypropylenes are used like bags, sacks, where polypropylenes are used for transportation and storage of fertilizer. Geotextile for drainage. So, we use for drainage, protective clothing for employees handling the spraying and hazardous equipments. So, that protective textiles are being used where the employees are being protected from the harmful chemicals, maybe mask, maybe gowns we use. Transport textiles for tractors, lorries, conveyors belts, hose, composite 10%, these are actually comes under transport textiles, but used in agricultural application. Next application is construction of building and roofing. The application areas are permanent construction like dam, tunnel, bridges, where we use geotextiles or fiber reinforced concretes. Temporary structures like tents, awnings are used, where textile structures are used for this building on and roofing. In architectural area, the architectural membranes are being used predominantly. It is mainly used in sports stadia, exhibition center, modern buildings. Non-woven glass and polyester fabrics widely used in roofing. So, glass non-wovens and polyester they are widely used in roofing mainly for insulation purpose. Some breathable membranes are also used for moisture penetration of wall. These are this acts as building and equipment insulation. So, this all this non-wovens and these membranes they act as insulation materials. So, double wall spacer fabrics filled with suitable material provide thermal and sound insulation. So, this spacer fabrics are used for sound insulation of a building. glass, polypropylene, acrylic, they are used for preventing the cracks in concrete or plasters. So, that is a fiber reinforced concretes are being used to prevent the cracks. So, glass is being used for bridge construction, carbon fibers are used for earthquake prone building due to its very high strength. It gives reinforcement with light weight. And during construction we use technical textiles in the area of safety nets, lifting, tensioning rope, flexible structure. So, for curing the concrete. So, these are the areas where technical textiles are used. In packaging and containment area, so it is bags of cotton, jute, flax, and gradually this cotton, jute, flax, these packaging materials are being replaced by polypropylene due to its higher strength, lower moisture regain and relatively inert chemical nature. Lightweight nonwoven and knitted structures are being used for wrapping and protecting products, mainly in food industry. Wetlet nonwoven fabrics are used for tea and coffee bags. Meats, vegetable, fruits are packed with a nonwoven insert to absorb liquid present in the product. Strong lightweight spun bonded nonwovens are used for courier envelopes. So, for envelopes used in courier purpose, we will see that we use spun bonded nonwovens nowadays, because it is a strong and lightweight. So, woven straps are nowadays being used and it is replacing the steel bands due to the environmental concern and due to its flexibility. In sports and leisure area, the performance clothing and footwears are being used due to their lighter weight, higher stretchability. Artificial turfs in sports surface, like in many sports we will see that the artificial turfs are being used. Carbon fiber reinforced composites are used for racket frames, golf clubs, fishing rods, cycle frames. These are the areas. Balloon fabrics, parachute, paraglider fabrics, sail cloths are used for sports. These are the very specific area of technical textiles. Geotextiles are used in civil engineering construction for their different applications. These textiles are used in conjunction with the earth for reinforcement or drainage or different other applications we will discuss in that segment. So, this area is predicted to be at most promising. So, the main use is the functions are reinforcement, separation, filtration, drainage, stabilization of earth. These are the different applications, dams, okay, temporary wall, erosion control. So, these are different application. Protective and safety clothing area, new generation high performance fibers like aramid are used in this sector. So, they have very specific applications depending on the requirement. So, that I have already mentioned, like fire protection, ballistic protection, chemical protection. So, these are the different application areas, and sensitive instruments are protected. For that we need electromagnetic shielding clothing to protect instruments, electronic gadgets. Ecological protection is also one area where technical textiles are important. These are used for protection of environment and ecology. In fact, this area overlaps many other areas like industry, industrial textiles, geotextiles, agricultural textiles. So, if we see this industrial textiles like or filter fabric, it is coming under ecological protection. Geotextiles, if we protect the soil, we are actually protecting the ecology. So, like that it is overlapping. So, we can say the textile can contribute in every sphere of their use, like by reducing weight in transport and construction, thereby saving materials and energy. So, as far as ecology is concerned, if we use textile product, we are reducing the mass, at the same time we are reducing the energy. So, indirectly we are protecting the ecology. So, that is all about basic introduction of technical textile. We have understood the application area, different types of fibers, and from next class we will start the specific area. We will start with the fiber reinforced composite. Till then, thank you.